Good morning. My name is Eric Spangenberg. I'm the GIS coordinator with the City of Helena, Lewis and Clark County. This morning, I'd like to share with you our experiences in developing a vehicle tracking app, specifically a snowplow app, using ArcGIS GeoEvent Server. What I plan to share this morning will just be a very high level overview of the what, why, and how we did what we did, how we set up the application and some of the queries we used. There will be a brief description of the GeoEvent server and its functions, basically looking at just the core components of it. And I'd also like to share some of the future applications that we'd like to use with GeoEvent. Now, unfortunately, what we don't have time for this morning are delving into the details, the gory details of setting up GeoEvent server and its associated parts, and also the specific details of the GeoEvent processes or the SQL views that we used. I will share a few tidbits about the processes in GeoEvent that we set up for our application, but I really don't have the time to get into the real down deep details of what went on behind the scenes with this. With that said, let's have some fun with this. So how did this all get started? Well, really, it's just all about snow. That's what it's about. We've had a number of winters here in the past couple of years where it's just been miserable. It got to the point where I even finally gave up and bought a snow plow. I mean a snow blower for our driveway and our sidewalk. I just got tired of waking up in the morning and shoveling every gosh darn day, and the streets showed it as well. It was pretty unbearable on some of the side residential streets. And with that being said, the City Commission tasked our transportation systems, our street department, along with our engineering office, to come up with and update their snow response plans. An example of that is their updated snow maps. We used to have a lot more snow routes. They whittled down the number of snow routes, emergency snow routes. And what that did is that when the plows finished those, it allowed them to branch out into the residential districts quicker. And that seemed to do a lot. Last winter, it was a difference between night and day in terms of the roads and how well they'd been taken care of. In addition to that, they also looked at a couple other things. One of those elements included the investment into the Verizon network fleet. Now, this uses automated vehicle location, AVL, and it's also a fleet management application. When I got involved with some of the meetings regarding the Verizon fleet and the asset management package, I was looking at some of the demos that they were giving, and I started thinking about, wow, why couldn't we develop an interactive map, showing the snowplow activity, showing where these vehicles are? I had this vision. I knew about the Esri local government solutions, and I knew specifically about the snow cop. I'd seen that, I'd read about that, and I'd always thought, wow, how cool would that be to have set up for our community. So I'm looking into that, and I see this GeoEvent extension mentioned. I'm also reading the Verizon network fleet documentation, and I'm finding that it's noting GeoEvent, and which really got me wondering, well, what is GeoEvent? And so, boy, did I not know the rabbit hole I was diving down into by asking that question. Well, GeoEvent is the Esri extension ArcGIS server that is a real-time that enables this real-time event-based data streams. Basically, this live data that comes in. Think about this GPS feed, things like that can be integrated into your enterprise GIS. You can filter it, you can do other processes to that data, and then push it out into other applications to represent that information. In our case, I knew that we had this real-time data. The real-time data was this AVL data feed from Verizon Fleet. And I'd seen in the Esri marketplace this Verizon Network Fleet connector. And so I knew that we had some ways to work with this. Continuing with that discussion, we found out that the street department, the transportation department, invested in GeoEvent. They were saying, yep, let's do it. We're ready to do this. And so we jumped into it. Now, I did contract with a vendor, thank you GIS Inc., one of the sponsors of this event, to help us with our install. They did our install of our GeoEvent server, our big data store, our portals, enterprise ArcGIS setup. Throughout this whole process of getting it started, During the install, I'm reading about GeoEvent and I'm reading about some of the work that we could do with it. And my vision is, man, I want that snow cop vision, if you will. I want to see the vehicles. I want to see where they're at. I want to be able to query and look them up and watch them moving around the community. And so I'm sharing that with the transportation director, and he's going, well, that's nice, Eric, but really what we want to see is we don't want to see the vehicles necessarily. We want to see the results of what the vehicles have done. In other words, they wanted to see, where have the plows and the sanders been? And they want to see it in a linear fashion. They want to see what roads have had service provided to them. That kind of put me back on my feet a little bit. It was a whole new twist in what I was previously thinking of doing. Well, thankfully, at the end of that one winter, I had a whole summer to delve into this new uh, plot twist, if you will, to develop this, to represent the work being done in the community. And so I had that summer to go through the GeoEvent tutorials, but I also do some research into what other communities were doing with GeoEvent Server. My research, I ended up finding a number of really great examples. You'll notice they're all Ohio communities. And yes, the Midwest does get a lot of snow. I'll attest to that. I grew up in central Wisconsin, and so yes, there is a lot of snow. And also, I'd want to point out, it's a testament to the GIS community as a whole. I reached out to these communities, Columbus, Dublin, and Hamilton, and each one of them, whether it was their GIS analyst, their manager, their database guys, all of them were so open and willing to share with us how they got to what they got. They were sharing their code, their diagrams, SQL statements, number of emails, back and forth phone calls. For example, Columbus shared their whole framework of their GeoEvent service. This is an example of what they have set up. And of course, when I first looked at this, to me, it looked like an electronic schematic. It wasn't until after I finished going through a number of the tutorials in GeoEvent that it suddenly started making more sense to me. So in addition to those folks, and also reaching out to the GeoEvent area in GeoNet, where I posted a number of things and had some great responses, it was a combination of those factors really got our feet firmly planted and got us moving with being able to develop what we developed. And so through all that, looking at these and seeing these examples, that next winter, we had something up and running. I'm happy to report it was not as difficult. Once that path was open for me, it was not a difficult process to move forward with this. And so we implemented this. And what we wanted to do, what the street department wanted to see, is that they wanted to see where service had been provided. What time, what are and based on a time, these service times. And so this is showing when a plow hit an area, whether the sander or whether the plow was used. And I'll talk more about how you determine whether it was plowing or sanding later in the session here. But it shows when it reached that area, when it went through that area, and then through a series of SQL views, we're showing this resultant data. And so it worked. It was great. It was a great example. But I'm ahead of myself. Let's back up. What is GeoEvent? What are these components underneath the hood that really allow us to do what we did? Well, the GeoEvent server is set up of a couple different parts and pieces. You have this input connector, which is your live data feed. In our case, it's the AVL feed coming from the Verizon Network Fleet application. Then you have these output connectors, basically where you're saying, I want this, I want it to come out into some product that I can end use. So like a feature service or an email notice based on something happening here. In our case, we're using a feature service that we're updating. Now, in between these two steps, you have either filters or processors that allow you to manage this data and manipulate it a little bit more on how you want to see it come into the output connector. So taking a look at each of those pieces, the input connector. In our case, this is that Verizon Network Fleet connector. There's approximately 18 of them that can be used to receive this data, this live feed, interpret it, and then be able to move forward with it. And as I mentioned, we didn't have to go out and use any of these out of the box or develop our own custom one. the network fleet connector, which is from Verizon, which is available from the Esri Marketplace, was our connector. So we didn't have to do anything fancy with it. We were just able to bring that in, set it up, and get it started. Now on the output side, again, you could see there's about 17 different connectors that are available that allow you to send this processed event data out for an end use. And you can see just a sample screenshot of some of those. In our examples, in our work that we did for creating these couple of these feature services that we built, we use update feature. So basically we go in on our server side and we create these features, this feature service that already contains a point file, if you will, and it is then being updated based on the input that's coming from the GPS feed. And so in our example, you could see where it's going, the service that's getting populated, what layer in that service gets populated, and then a couple of things about how long do we want to keep a feature before it's removed, what's the frequency of checking and deleting old features, things like that. And is it an update only, yes or no, along those lines. So in between that input and the output are these elements of the filters and the processors. Now there's roughly 5 filters that allow you to do things, and a filter is just like you think of as a filter. Think of a select statements, if you will. You can do it as a spatial side or an attribute filter. And in our case, you can see the filter properties that we used here. We have one filter where we are actually taking a look at the Verizon feed that comes in, and we say we only want to work with the GPS feed that's coming from the network. There's a whole bunch of other things. They have a sensor, they have a number of other feeds that come in, but we only want to work with the GPS filter. And then to further filter that, we have another one that's built up that we use 2 geofences, basically. We want to say, we're not interested in seeing the vehicles that are sitting at the bus depot, and we don't want to see all the vehicles that are roaming around at the streets and maintenance shop. So we only want to see those vehicles that are outside of this geofence, if you will. So it's some geometry that's been drawn around each of these facilities that is used to mask anything inside it. We only want those features outside of it. And then additionally, after we've done some enhancing to the input feed, we only want to see vehicles that are a plow truck with a sander. Now at the processor side, these are some really cool things that you can do with it. There's about 25 of them. We're only barely touching, I'm barely scratching the surface of what's available with these. But with these, we're performing some really neat actions that allow us to enrich some of these fields, as well as add additional fields to the output feature. And so our processor here, this is an example where we're taking and we are field mapping, if you will. We're taking, here's the source feeds from the Verizon, and this is what they match up to in the target fields in our feature service. And so we're saying this is equal to this. And so we're lining out how the data needs to be mapped to that new feature. And then on the other end, we're also doing a thing because, as you noted, we have to take this point file and we need to be able to we end up creating this spatial join, if you will, this spatial view between the point feature and our linear streets feature. And so what we've done there is that we have a feature, the street buffer. And what happens is it identifies when, in the processor, it identifies the point, the GPS point from the input. It says, oh, you're here, you should be tagged with this street ID. And so it'll tag that point with the existing, with the street ID that's available. Also examples of that later on here in a minute. And so that's a geotagger one. So we put us all together, taking all that together. Here's our input, the network fleet. We filter out to only be looking at the GPS component. We field map it. This is the case where we're matching up fields from this and how they match up to the fields in this one. A field enricher, this is where we add a couple additional fields. Some of these additional fields that are added here, we enrich those with some new elements. For example, the vehicle label. is it a plow? Is it a sander? Is it a sweeper? As well as the, I'm sorry, the label is the number. So you're saying on the radio, truck 311, where are you? That type of thing. And then this filter, as I mentioned earlier, is the one that only lets us see those vehicles outside of the shop and the hats area. And then this being that geotagger, this is the one that takes a look and says, okay, you're on this street, tag that point with this street ID so that we can then take and create a spatial join later saying at this time, this street had this service. And it comes out to this end feature service. Putting it all together results in a couple GPS. It results in this end feature service. So the feature update results with all these attributes. So here we have the vehicle coming in, and these fields right from here, these are all fields from VIN down to age and miles. These are elements that are coming from the network feed, from Verizon Network's GPS AVL feed. Now, in the previous slide, when I showed you the vehicle label, the field enricher feature, we're taking and looking at a feature service that enables us to identify and label then, based on VIN number, we are able then to label this new thing with the vehicle's number as well as what it is, plow truck with sander. The additional step then with this geotagger processor allows us to then identify this point was within a buffer along this street. This street has a given ID, and this ID from this street is now being geotagged to this individual point. Now, the rationale behind that is, like I said, we do a spatial view later on where we're matching up these times on these points with the end street so that we can then show how that is represented in a time fashion. Taking a look at all this together, this shows you, here's these vehicles. You could see based on their, symbolized based on their vehicle label. And then also the second component to this whole set is another feature service that is run using the same processes previously shared, but this one is creating a sensor one. This one's creating a point telling you whether the sensor was on or off. Now, in order to, in the vehicles, there's a sensor button that when you toggle, in other words, you're toggling to turn on the sander or you're toggling it to drop the plow, that is tied to the sensor feed in the Verizon Network Feeds AVL. And so we need to know when the plow, not only when the plow is on this street, but whether that plow is on in a on state or an off state. Because if it's here on the map and it's on, then that gets geotagged, and then that's how we identify that street had a service at a specific time. Through the series of spatial views, we end up creating where we're able to now take this and be able to show, be able to represent that point data now into this linear fashion. And so you can see here that when you identify a given street, it tells you, yep, it was there at this time, this is the vehicle, the sensor state was on, that type of thing. And so we end up creating these, a series of spatial views that we are then using within our web mapping application to represent how and where plows have been. Like I said, this is very brief. We are only scratching the surface of the behind the scene details, but it worked out, and again, wouldn't have gotten this far without help from many in the GIS community. Now, on the future side of things, we've been working with our transportation office, GIS staff there, and to integrate this Helena Fleet Service with the CityWorks asset management. We've been actually kind of successful at that already. We've been kind of toying with that. I know that they were using it. We want to set up more automated scripts, and we're going to do that for sweepers. And actually, I did that this past summer. This past summer, I was able to have a sweeper app up and working. My eventual goal is I'd like to do a story map where I contain both a plow and a sweeper app within a tabbed area that people can just go to one spot and be able to pull up either one. The web, I want to improve these web apps, these maps, make them look a little bit better. Uh, let's see, there is a new timestamp SQL query that I'm really excited to try out with this term called interval queries. There's a blog post about that we can look at, that you can feel free to look at. And I'd like to see something from the HAT side of things. That's our Helena Area Transit Service. I'd love to see something where we could show the buses as they move through town, that kind of thing. Let people be able to see, oh, where is the bus? How long should I be standing here waiting for something? You know, that type of thing. And if you're interested, this is our final setup. Hopefully I've removed any things like that, but you could see where we have our ArcGIS server, our portal and web server, GeoEvent here that can feed the big data store. Right now I have, this coming winter, I'll be actually pushing the breadcrumbs, if you will, the data breadcrumbs to our big data store, so that we all will have a perpetual history of where plows have been. So. And with that said, my time is up here. I'll be more than happy to answer the questions to the best of my abilities, and I'll leave my contact information available on the virtual app, on the conference app, and happy to answer any questions at this point in time. Thank you.